Hi, it's Alan from Crashtest Security. In this video, I will tell you more about block ciphers, what they are, their operation modes, and examples of block ciphers. So let's get started. What are block ciphers? Block ciphers convert data in plain text into ciphertext in fixed-size blocks. The block size generally depends on the encryption scheme and is usually in octaves, 64-bit or 128-bit blocks. If the plaintext length is not a multiple of 8, the encryption scheme uses padding to ensure complete blocks. For instance, to perform 128-bit encryption on a 150-bit plaintext, the encryption scheme provides two blocks, one with 128 bits and one with the 22 bits left. 106 redundant bits are added to the last block to make the entire block equal to the encryption scheme's ciphertext block size. While block ciphers use symmetric keys and algorithms to perform data encryption and decryption, they also require an initialization vector for to function. An initialization vector is a pseudorandom or random sequence of characters used to encrypt the first block of characters in the plaintext block. The resultant ciphertext for the first block of characters acts as the initialization vector for the subsequent blocks. Therefore, the symmetric cipher produces a unique ciphertext block for each iteration, while the for is transmitted along with the symmetric key and does not require encryption. Block encryption algorithms offer high diffusion, that is, if a single plaintext block were subjected to multiple encryption iterations, it resulted in a unique ciphertext block for each iteration. This makes the encryption scheme relatively tamper-proof, since it is difficult for malicious actors to insert symbols into a data block without detection. On the other hand, block ciphers have a high error propagation rate, since a bit of change in the original plaintext results in entirely different ciphertext blocks. Block cipher operation modes. Several block cipher modes of operation have been developed to enable the encryption of multiple blocks of long data. These modes fall into the following two categories. Confidentiality-only modes. The confidentiality-only cipher mode of operation focuses on keeping communication between two parties private. These modes include Electronic Codebook (ECB). In this mode, plaintext messages are divided into blocks, where encryption is applied to each block separately. The ECB cipher mode does not hide data patterns well, since it lacks diffusion, and is usually not recommended for security frameworks. Cipher Block Chaining Mode (CBC). This mode combines ciphertext from the previous block with current plaintext blocks using an XOR, exclusive disjunction operation before performing the encryption, and for is applied to the first plaintext block in a CBC mode to ensure uniqueness. Propagating Cipher Block Chaining (PCBC). In this mode, the encryption scheme performs an exclusive disjunction between the current plaintext, the previous plaintext, and the previous ciphertext before running the encryption algorithm. This causes minor changes in the ciphertext to propagate indefinitely during encryption and decryption. Authenticated encryption with additional data. This mode of operation for block ciphers ensures data authenticity and confidentiality. This mode can be further subdivided into Gallows Counter Mode (GCM). Uses an incremental counter that generates a universal hash over a finite binary field, Gallows field, to generate message authentication codes before encryption and decryption. Synthetic Initialization Vector (SIV). This block cipher uses an encryption key, plaintext input and a header, authenticated variable length octet strings, to enable authenticated encryption. SIV produces a deterministic ciphertext that keeps the plaintext private, while ensuring the authenticity of both the header and ciphertext. Examples of block ciphers. Block ciphers form the basis of most modern cipher suites. Some commonly used block cipher encryption standards include Data Encryption Standard (DES). A 56-bit symmetric key algorithm was initially used to protect sensitive confidential information. DES has since been withdrawn due to short key length and other security concerns, but is still viewed as a pioneer encryption standard. Advanced Encryption Standard (AES). A popular block cipher that encrypts data in blocks of 128 bits using 128, 192, and 256-bit symmetric keys. The underlying block cipher uses substitution permutation and transposition techniques to produce ciphertext by shuffling and replacing input data in a sequence of linked computations. AES is a globally accepted encryption standard since cryptanalysis efforts against its algorithms have been unsuccessful. Twofish. Twofish is an encryption standard that uses a Feistel network, a complex key schedule, and substitution techniques to separate the key and ciphertext. The standard encrypts plaintext data in blocks of 128 bits, with flexible key sizes between 128 and 256 bits long. Other encryption schemes that use block ciphers include 3DES, Serpent, and Blowfish, among others. Try Crashtest Security today to discover how it integrates into your development stack for efficient, automated vulnerability scanning. The trial is free. Also, subscribe to the Crashtest Security channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for watching, and see you in our next video.